e poi ha costruito la sua carriera principalmente all'Università di Potsdam in Germania. Lei si occupa di animal cognition e non solo, anche in contesti di global warming. Oggi parlerà di Smart in the City come argomento generale, Individual Difference in Innovation of Rural and Urban Small Animals. Però prima di dare al volo la parola a Valeria per il suo seminario, vogliamo fare un breve annuncio come direttivo, perché il collega e amico di molti noi e anche, insomma, ho lavorato con lui tantissimi anni, Augusto Foà ha pubblicato un libro dal titolo Colombi e binocoli, lucertole e cronometri, studi sull'orientamento animale e altro, perché chi conosce come Elisabetta, come il sottoscritto, insomma, la carriera di Augusto, credo che sia parte del suo percorso scientifico nel corso della vita. Quindi Augusto è stato per tanti anni, è ancora, non so ancora se è socio o no, insomma, dell'associazione, è stato sempre partecipe, quindi ci tenevamo a far presente questa.
Non ce l'hai da mostrare la copertina?
Sì, ce l'ha, e non,
Casa
forse
editrice?
la casa editrice Unicopli di Milano, e credo che Christian, hai la copertina?
La trovo anch'io, aspetta.
La recuperiamo adesso, ok?
Sì, insomma,
Vabbè, ma
per
la trovo in
mostrarvela.
rete, e se ce
Sì,
l'avevi
sì, ha detto sì, no, ma ce l'abbiamo, ci ha mandato anche
Sì,
la
abbiamo
parte di
fatto anche il
copertina.
post su Facebook con la copertina.
E allora vado a vederlo lì, dai, non perdiamo
Ok.
tempo.
Va bene, allora Valeria, a te, grazie mille, e domande in fondo, ok? Prego Valeria.
Grazie Cristiano, e grazie mille per questo invito, grazie per essere qui con un orecchio ai vari consigli e alle altre riunioni, o essere qui di nuovo perché vedo almeno un paio di nomi che hanno già sentito una forma di questa presentazione, quindi grazie infinite. Tra un attimo passo all'inglese in caso si colleghino altri partecipanti. Intanto vediamo di condividere la presentazione. Vedete la modalità di presentazione adesso? Tutto a posto? Perfetto. Ok. So welcome again, and thanks a lot for being here so close to Christmas time, and to hear a little bit about individual differences in innovation in rural and urban small mammals, the focus of my recent research. The reason that got me to investigate this topic is that, as you certainly know, we are living in an age of drastic environmental alterations that is facing wildlife with challenges and environmental changes that have never been encountered before in our evolutionary history. And these alterations sometimes are often referred to with this umbrella term of human-induced rapid environmental change, and they incorporate the introduction of pollutants into the environment, land use alterations, overharvesting, the introduction of invasive species, and of course climate change. And while some of these alterations have been produced by human activities since humans have been around, it is the scale, the magnitude, and especially the rapidity at which they are happening that they are giving cause for concern, and they are posing such a major threat for most other forms of life. One specific case of land use alteration is urbanization. And I'm particularly interested in that because in urban habitats, animals are facing most of these changes and challenges all at the same time. And for example, they have to deal with major human disturbance and presence, a biotic community that can be altered regarding competitors, predators, or parasites for which there might be not effective defenses in place yet. Familiar resources are lacking, new resources are there, waiting to be exploited, but maybe not yet familiar. Fragmentation, plus all kinds of pollution, including artificial light at night. And in this situation, behavior and cognition can provide an effective first line of defense for individuals to deal with changes in their environment, because behavior and cognition are the interface between animals and the decisions that they have to take day to day to deal with their surroundings, both social and abiotic. And one specific instance of cognitive process that can be particularly valuable in here is innovation. Innovation can be defined as the ability to apply novel solutions to old problems, but also the ability to find solutions to problems never encountered before, which leads to new or modified learned behavior, ultimately introducing novel variants into populations' behavioral repertoires. Famous examples of innovations include the potato washing by macaques, the opening of the milk bottles by great blue-tits, and this amazing crows dropping nuts in front of cars to open them. And hands up if you have seen some of them doing it. It was pretty common where I lived before in Germany, and it started I think in the other side of Asia a decade ago, and now it's spreading, and we can see it happening here. And if you haven't, I guess give it a few more years and the crows in your region might start doing it too. So for this ability to provide solutions to issues never encountered before, innovation can offer a very effective buffer against environmental variation. And as such, it is considered a key factor in the successful establishment and permanency of animals in new or altered environments, like, for example, human-altered environments like cities. And in fact, what we know so far is that species at the species level that are more innovative, so they present a higher rate of innovation, they actually are at a lower risk of extinction, according to the UCN. And in this very nice review, we have a perfect summary of what we know about the role of innovation in the context of environmental change and human-altered environments, and also all the things that we do not know. For instance, as you can see here, this amazing review was conducted about birds, because a lot of the behavioral and cognitive research that is available for us today deals with alien taxa, leaving more of a question mark regarding all the species that have a more limited dispersal potential and that cannot just fly away when situations become unbearable, and potentially in which the selective pressures can be stronger. Also, as you can see here, we're talking about species. And we still don't know much about all the amazing and incredibly wide variation that exists within a species regarding all kinds of cognitive abilities. We do know that coming up with an appropriate behavior every time something novel comes up requires a degree of behavioral flexibility that can be cognitively demanding. And for this reason, we do expect huge variation within species. And for these reasons, this is why I undertook this kind of research, and the two studies that I will be presenting today, mostly dealing with, first of all, an investigation of intraspecific variation in innovative problem solving, and a quick look at possible underlying mechanisms. And second, what does innovation or innovativeness mean in different contexts for the same animals. The study species are several species of small mammals, and that are commonly found in rural and urban environments throughout continental Europe. All the results that I will be presenting, they come from intra-specific comparisons, but the same studies have been conducted for these species, although there will be a bit of a bias in favor of striped field mice. But I am telling you this because our findings all go in the same directions, and what you see today mostly deal with striped field mice. And similarly for the study sites, these studies have all been carried out in different locations within the urban habitat provided by the city of Berlin. and the agricultural or natural reserve landscapes in northern Brandenburg. And if these pictures here don't give you an idea that we are talking about a rural and an urban environment clearly enough, you can see here that we also quantified a proxy for urbanization as a ceiling index, so the percentage of soil that is covered by impervious surface that is known to also relate to the number of people that live in the area, the amount of traffic, the light pollution, and so on. So starting with variation in innovative problem solving, what we aimed to do here was not only to look at whether rural and urban small mammals do differ in problem solving ability and performance, but also try to investigate the mechanisms that could underpin this variation in innovation. And based on the literature, we focused on 3 non-cognitive aspects that are usually explaining variation in innovation performance, namely the persistence, so targeted behavior towards specific goal, motor diversity, so how wide the motor repertoire is for any given individual, and finally their personality or temperament. So what we did was to test in captivity a number of wild-caught individuals that were presented with a battery of 7 foraging extraction tasks. And the first 4 of these puzzles had multiple solutions. So you can see there is a puzzle box that animals have to open to access a food reward inside. And there are several ways that these first 4 setups can be opened. The lids can be pushed or pulled or bitten away or lifted, although each solving action had to be repeated several times to avoid random occurrences of opening. And in the second half, the last 3 setups only had 1 solution, meaning that there was only 1 motor action that would actually open the puzzle box. In this case, it was lifting the lid, or it could have been pushing forward only, and this would have helped us differentiate between solutions that happened through a diversity of motor actions from solutions that actually came from actual innovative performance. We also had to control for motivation, because animals in the lab, they are well fed, they might not like what we have to offer, and so not be motivated enough to engage with any kind of setup. So we offer the same kind of reward in a control setup where animals only had to dig through the bedding to reach the food reward. And digging for food is an innate behavior and totally normal for these mice. And what we found was that in this control task, both rural and urban animals were performing equally and equally well. So they were motivated to engage with the setups, and they could easily find the food just by expressing their innate digging behavior. When it came to the problem-solving test battery, though, we found that urban animals were solving more puzzles compared to their rural conspecifics. So they were basically better at problem solving. Coming to the non-cognitive mechanisms, we found here that in case of success, the time it took for animals to successfully open a setup was really comparable between rural and urban individuals, whereas in case of failure, it was the rural mice that were a lot more persistent compared to urban individuals that would just give up after a few seconds, whereas the rural ones just kept on trying. Coming to motor diversity, we found that urban animals were outperforming the rural ones in both groups of setups. The ones where there were multiple solutions here on the left, and the ones that only had 1 solution on the right. So motor diversity was not explaining the variation in the success. or in the performance of these animals. Finally, personality did have a connection with the problem-solving performance, with animals that were bolder and so more prone to take risks, performing better or having higher chances of successfully opening the puzzle boxes compared to animals that were shyer and more risk-averse. So to sum up what we found in this lab study regarding the differences in innovative problem solving between rural and urban small mammals was that urban mice were overall more successful, so they were more innovative compared to rural conspecifics. And regarding the mechanisms that underpin this variation, we found that neither persistence nor motor diversity explained the variation in our case, but personality and specifically boldness and also activity were explaining part of this results. This, however, left us with more questions than answers, and so we took the chance of asking more questions, and this time repeating the study, having a look at how innovation plays out across different contexts. And specifically, the reasons behind it is that when we talk about innovation in general, we use one catch-all term to include a variety of contexts, of behaviors, of scenarios in which animals can express novel behaviors. In this nice review, the authors even just, again, this was just about birds, but there were no less than 12 categories of innovations, spanning from nest building to anti-predatory defenses, to technical innovations like novel foraging techniques or dietary innovations, so novel foods that could be incorporated into the diet. And when we talk about innovation, like this is one thing, we assume that individuals that are good innovators in one context are good innovators in another. But do we have enough proof of that? So I was not convinced. And this is why we did basically two things. We compared innovation and problem-solving performance of rural and urban small mammals, this time in the wild, to be sure that what we found in the lab actually had say a counterpart and relevance also in the real world, where these animals might really need their innovation propensity. And second, we assessed performance of the same individuals across three different contexts. One was the dietary one, so we tried to see whether they would incorporate novel food into the diet, and two problem-solving contexts, one with the foraging extraction tasks that I presented before, and the non-foraging context represented by an escape test. We individually marked a number of animals across the same sampling sites that I showed you before. We tested these animals for personality and their capacity to escape unpleasant situation, a box. And afterwards, we left them completely free in their own environment to freely interact with the novel food and the problem-solving tasks. And this is a little insight into how we did it. We used this so-called spy boxes, so a system where a camera trap can monitor a little space where animals can feel safe enough to come willingly and interact with different kinds of setup. You just saw a mouse opening one of the puzzle boxes, and this is what a video from a spy box looks like. And this one is, of course, a foraging innovation tests where a bank vole seems to be pretty convinced by our offer of little tofu cubes. So this is what we found regarding the novel food. We had a bit more than 1,000 visits, and in most of which the animals that entered the spy box did approach the food. And of those that did approach, the majority of urban animals chose to eat and try the novel food, whereas a little more than half of the rural ones did so. And in this case, I'm just talking about visits, and this is because together with our marked animals, a ton of unmarked animals also came along. So when we zoom in into the animals that we know for sure we can identify with certainty, then we have, of course, a much smaller sample size, but the pattern remains the same with urban animals that are more likely to incorporate and try novel food and come repeatedly and make it part of their short-term diet. They were also showing shorter latencies to approach the food. So they were faster in getting close to the food. They were faster in deciding to eat it, and they would forage on it for longer compared to the rural animals. Coming to the extraction tasks, most of the animals that entered the spy boxes engaged with puzzle boxes, so tried to open them. And again, most urban animals were successful in most of their visits, whereas only half of the rural ones could successfully open the puzzle box and get the food reward. Zooming in on the individual level, we found that urban individuals were indeed faster in finding solutions to most of the problems. So this, however, has really not such a good sample size. So we repeated the same experiment for a second season, and we are almost done analyzing the videos. So hopefully this will be confirmed, but in any case, we will have the more robust data to really back this up or not. So take this with a pinch of salt for now, and stay tuned. Somehow a similar pattern was also shown in the escape test, so the non-foraging problem-solving task, where urban animals were faster in finding a solution. So they were much faster in figuring out the way to escape. And they were doing so consistently across different kinds of solutions that were offered to exit the box. And in all of these cases, we still found a connection with the personality of these animals. Here again, I present the results about boldness. And so this is somehow in line with what we found also in the lab. And bolder animals were faster, so they had shorter latencies in escaping and in solving the puzzles, and they were also more likely to eat all kinds of novel food that we presented. Finally, coming to the performance across the different tests, well, we found very, very little. So we basically found little to support this idea that individuals that are good innovators in one context perform equally well in another. And again, this is of comparatively little sample size, so we are waiting for the results for next year. Sorry, for last year, but so far we only found some correlations between how quickly the novel food was eaten and how frequent the foraging tasks were solved, or whether or not the escape test was successfully solved, which is actually not the strong connection that one would expect, finding the generality of innovation that is usually presented in the literature. Then again, this is also something that is a very preliminary result, and we'll see what happens. So to sum up, what we found so far is that urban small mammals show a higher expression of innovative behavior and behavioral flexibility compared to the rural counterparts, and that both in the lab and in the wild, the personality seems to mediate the expression of innovative behavior, leading us to the conclusion that improved problem-solving performance seemed to be linked to living in human-altered environments like cities, and so that innovation could really be key also for these animals in successfully coping with the challenges of anthropogenic change. Okay, this is this is it. Let me thank again my colleagues and especially the students, the Animal Ecology University of Potsdam, that were fundamental in conducting this research and analyzing these thousands of videos. And also thank you all so much for being here and listening. I'm very happy to take questions.
Grazie mille, Valeria, per la